Imagine a breakthrough that could dramatically accelerate the capabilities of quantum computers. Sounds exciting, right? This is exactly what a groundbreaking new device, known as a quantum router, promises to deliver. But here's where it gets controversial. Could this innovation truly unlock the full potential of quantum computing? Or are we still facing major hurdles? Quantum computers are poised to revolutionize computing by solving complex problems much faster than classical computers. One crucial challenge, however, lies in efficiently managing data inside these advanced machines. Just as traditional computers rely on random access memory, RAM, to quickly store and retrieve data during operations, quantum computers need their own version called QRAM, Quantum Random Access Memory. At the heart of building a functional QRAM is a special kind of router, but not the internet router you use at home. Instead, it's an internal device designed to direct quantum information to the right places within the computer. Enter the team led by Connie Miao at Stanford University, who have successfully developed one of these elusive quantum routers using superconducting qubits. These are tiny circuits cooled to very low temperatures to exhibit quantum effects. Think of qubits as the fundamental units of quantum computing, somewhat like bits in classical computing, but with the extraordinary ability to exist in multiple states at once, thanks to quantum superposition. What makes this quantum router stand apart is its ability to route information not just to one fixed address, but to a superposition of two locations simultaneously. To put it simply, the router can send quantum data in a way that makes it impossible to determine exactly where the data is stored, a phenomenon believed to underpin the power of quantum algorithms. The team tested their device with 3 qubits and achieved about 95% fidelity, meaning it operated with impressive accuracy, though not perfect. This advancement is crucial because it represents a practical step toward realizing QRAM. Previously, researchers could only theorize about QRAM's potential or create devices that worked inconsistently. For instance, Luming Duan's group in China earlier developed a quantum router that only functioned sporadically during experimental runs. The new, more reliable router from Stanford moves us closer to practical quantum memory and opens doors for exciting applications, such as quantum machine learning, which merges quantum computing with artificial intelligence to process data in novel ways. David Schuster, a member of the Stanford team, highlights the broad range of possibilities this technology unlocks. From enhancing algorithms that search large databases far more efficiently than classical counterparts, to establishing quantum IP addresses that could underpin a future quantum internet, there is much to explore. And this is the part most people miss: the full scope of how quantum routing could reshape not only computing but the very infrastructure of communication. However, the road ahead is not without challenges. Sébastien Laguerre, another expert on the project, notes that the current version of the quantum router still falls short of the reliability needed for some of its envisioned uses. To make it truly practical, engineers must reduce errors and scale up the number of qubits it contains. Scaling quantum systems while maintaining performance is a notorious challenge in the field and remains a key obstacle for realizing robust and large-scale quantum machines, including supercomputers predicted to emerge in the next decade. So while this quantum router could represent a major stride forward, it also sparks debate. Are we overestimating how quickly this technology will transform computing? Or are these advances genuinely on the cusp of a quantum revolution? Given the implications for everything from cybersecurity to artificial intelligence, your thoughts on this matter are highly valuable. Do you believe quantum routers will soon become the backbone of powerful quantum computers? Or is the hype outpacing reality? Share your views and let's dive deep into this quantum conundrum. For those interested, the scientific study detailing this work is soon to be published in the journal PRX Quantum.